Hi guys, today we're going to learn about the equilibrium constant, or Kc. Imagine you have an equilibrium reaction as seen above, where the lowercase letters are the coefficients and the uppercase letters are the species. Note that these chemical substances must be in the same state of matter as each other, i.e. all gas or all aqueous. You can have heterogeneous ones, but they're beyond the scope of this course. Also note that when we do mathematical calculations using this, we need molar concentrations, and you can't have a molar concentration of a solid or a liquid, hence VCE sticks to aqueous and gases. How to write the Kc expression, or Kc, don't forget, is equilibrium constant. Square brackets is molar concentration. So it's the molar concentration of the products multiplied together raised to the power of their coefficients divided by the molar concentration of the reactants multiplied together raised to their coefficients. I.e. it tells you how much product you get per amount of reactant. So if the value for Kc is high, it means you get a high yield. If it's low, it's a low yield. What is yield? It's how much product you get for a given amount of reactants. So if Kc is somewhere between 10 to the negative 4 and 10 to the positive 4 as a value, it indicates that there's a considerable amount of reactants and products available, so the reaction is considered to be at equilibrium. Kc is an indication of yield, not rate. It doesn't tell you how fast the reaction will occur, it just tells you how much product you're going to get for a given amount of reactant. Note it is a constant, so everyone in the world will have this same value, except it is temperature dependent. So for exothermic reactions, if the temperature goes up, the value for Kc goes down, i.e. yield goes down. So if you were an industrial chemist and you had an exothermic reaction and you want a high yield, i.e. a large amount of product, don't increase the temperature. For an endothermic reaction, they're the same as each other, so if temperature goes up, the yield goes up. Now, one way of remembering this is an X. Put your arms up like in the shape of an X, i.e. they're opposite to each other. For N, basically put your arms up straight. They're going the same as each other. We are going to do this in a lot more detail later, but at the moment in your notes, put a big box around it. Okay, units of Kc. Interestingly, this is where the Education Perfect get it wrong, so I want you to ignore what they say. It is correct in the textbook, by the way. So here's a given reaction. Ammonia, 3 hydrogens makes 2 ammonias. The Kc is the concentration of ammonia squared divided by the concentration of nitrogen times the concentration of hydrogen to the power of 3. Note for this one, the unit is m to the negative 2. Where did I get that one from? Because a square brackets means molar concentration, that's the same as molar squared divided by molar times mole cubed. Know your laws of indices, and you end up with m2 divided by m to the power of 4, which is m to the power of negative 2. Note the unit will depend on the actual reaction. So for example, here's another one. Note this time, when you put the whole expression in, the concentration is just m. It doesn't have a number, i.e. it's raised to the power of 1, i.e. m8 divided by m to the power of 7 equals just m. Alright, I'd like you to have a go this time. So I've given you a reaction. I want you to pause the video once you've written down the reaction, and I want you to write down the Kc expression. You should have this. Now I want you to write down the units. But there's no unit for this one. They all cancel each other out, so they don't all have a unit. Have another go. Here's another reaction. I want you to write down the Kc expression for this one, including the units. And you should have this, which is m to the negative 6. Okay, the next thing we're going to look at is the relationships of Kc. Not that they're friends with each other. It is covered on page 208, by the way, but i.e. what happens when we change the reaction. So here's a particular reaction. I've written out the Kc expression. I've called it Kc1 because it's for reaction 1. I've now changed that reaction. As you can see, I've doubled all the coefficients and I've called it reaction 2. So I've written out the expression for Kc2. Note, in this case, Kc2 is Kc1 squared, i.e. whatever you do to change the mole ratio, raise Kc to that power. If you tripled the coefficients, Kc2 would be Kc1 cubed, or if you halve the coefficients, it's the square root of Kc1. This is going to become important when we put numbers into all of this. Here's another relationship for you. So here's the first reaction again, and it's Kc expression. This time, what have I done? I've reversed it. So when you reverse it, as you can see, Kc2 is the reciprocal of Kc1, i.e. 1 over Kc1. I want you to try this question. Write it all out, or just have a look at it on the screen, and it's multiple choice. Which one relates K2 to K1? Note, I've got rid of all the little c's to make it easier for you. So I want you to pause it and work out the answer. You should have the answer being E, i.e. the reaction has been reversed and the coefficients have been doubled. Thank you.